A support vector machine is a model that classifies data by finding the best possible boundary between two groups. Say we have two classes of points, and we want a line that separates them. Many different lines could split them, but which one is best? An SVM picks the line that stays as far as possible from the closest points of either class. That gap between the boundary and the nearest points is the margin, and the SVM makes it as wide as possible. A wide margin means the boundary is decisive. It tends to generalize better to new, unseen points. The few points sitting right on the edge of that margin are the support vectors, and remarkably, they alone define the boundary. Move a point that's far from the boundary and nothing changes, but move a support vector and the whole boundary shifts. On screen, that boundary is just a line, w times x plus b equals 0, positioned to make the margin as wide as possible. The SVM finds w and b by solving an optimization problem. Pick the boundary that makes the margin as wide as possible while keeping the two classes on their correct sides. To classify a new point, you just plug it into w times x plus b. If it comes out positive, it's one class, negative the other. The sign tells you which side of the boundary it's on. However, real data is rarely perfectly separable, so an SVM allows a few violations to keep the margin wide. This trade-off is controlled by the parameter c. A lower c allows more violations, for a wider margin, while a higher c penalizes them more, shrinking the margin until the closest points become support vectors. C is usually tuned with cross-validation. But what if the classes can't be separated by a straight line at all? Here's the clever part, the kernel trick. An SVM can behave as if the data had been mapped into a higher dimension, where a straight boundary suddenly works, without ever actually computing that mapping. Picture those points lifted into that space. Now a flat plane splits them cleanly, and that plane becomes a curved boundary back in the original 2D picture. That's a support vector machine, the widest, most confident boundary between classes.